My name's Paul Needle. I'm in the systems practice in the UK. I'm going to run you through the ZFS Discovery Day technical presentation and demo over the next 45 minutes or so. We put the scripts together in the UK to try and help people to better understand the capability from an administration point of view of the ZFS file system. So I've been working in the field for around 8 years now for Sun, and setting up systems on site for different customers, demonstrations, all that sort of thing. And I first used ZFS in a university in London and read the admin guide on the way in, and had basically to set up a 48 disk thumper system with a single storage pool, multiple file systems across all of the disks in that node. And I was used to using Solaris Volume Manager, setting up Sunray servers, all that sort of thing, and using the stat, metadb commands, and thought that it would take a considerable amount of time to get these disks configured. And when I actually got on site, I went through the admin guide with the customer, and we put one command in, which was a zpool create command. And for me, I really felt a bit of a wow factor for ZFS, because the command was, fairly simple in its structure. And we actually created a pool which incorporated the 46 remaining disks within that thumper system. I pressed return, and then 3 seconds later I came back to the command prompt, and I anticipated that in the background disks would be synchronizing and things would be going on for several minutes, but in actual fact it had worked and it was complete, and we had pretty much 20 terabytes of usable storage space which we could then start throwing file systems at there and then. For me, that was a very welcome change, which kind of refers back to some of the things that Tim Thomas was talking about in the earlier presentation today. So I wanted to encapsulate that and show people, try and portray that wow factor for other people. So in the UK, we've written a number of scripts that pull together all of the various admin commands and all of the various facilities from within the ZFS command set, and try to demonstrate those in a succinct way. So in the CBC in London, we have some equipment which you can see on the slide here has been set up in such a way to demonstrate the scripts. For this particular part of the presentation, for this particular demonstration, we'll be using an X4240 and also an X4100, which actually isn't on these slides. The 4240 is connected to a J4200 JBOD via a SAS connection, and we're just basically using 6 disks from that to configure storage pools and throw different file systems at those. And then we have a remote node which is just connected on a gigabit Ethernet network, which we'll use towards the end of the demonstration to illustrate the send and receive capability from within ZFS. So moving on to the next slide. So the first time we run through the life cycle of a file system, we'll just simply create a basic pool and then create a basic file system on top of that. And then for me, the most succinct part of this will illustrate using ZFS get and ZFS set how you can actually change the properties and inheritance of file systems and their successive child file systems very quickly and very easily, making file systems a focal point for administration and control, and giving you very granular control, for example, over home directories. So we would recommend as best practice with a ZFS file system, if you're running file management services, home directory services, that each user's home directory actually becomes a file system in its own right, and that way you can change settings very easily, such as the amount of space that you want to quota to a particular home directory. And that way, using property inheritance as referred to by Tim in the main presentation, you can make broad sweeping changes to home directories in one fell swoop. So we'll explore some of the properties that are around, and the more we develop Solaris, the more control you'll actually find within the ZFS set and ZFS get commands. We'll then destroy the file system and destroy the actual storage pool, and then move on to looking at more advanced capabilities. All of the pieces that you see on this particular slide here are fully functional within the set of scripts, which are actually downloadable from sun.com. Today, for the purposes of this presentation, we're going to run through maybe the first 5 or 6 in the interest of time and just to give you a taster as to what's possible. We'll probably finish off with looking at send and receive onto the remote host, but that should give us the ability to demonstrate snapshotting, cloning and some of the main features. But feel free to download the scripts and have a look around. Anything that you can pretty much find in the sysadmin guide is possible in there as well. So it also acts as a good training aid if you just want to download and play around with ZFS in your own free time. So it's important to distinguish between the output that's generated by the menus that we've created and the actual ZFS commands that are being run. So it's not to kind of divulge from the message that ZFS is very simple. So all the way through I'm going to point out specifically when we're actually running ZFS commands. For the most part, this menu sequence that you see here pretty much just generates ZFS commands, and it's just a way of stepping through all of the various possibilities. So initially we're going to run through the basic menu, creating a storage pool and file system as I mentioned, and then we'll have a feel around inside the system properties and what you can do with ZFS set. So initially I'm going to create a ZFS storage pool. So the disks that are currently available are listed here, and these are 6 of the disks that are in the J4200 that I brought up on the slide earlier on. So to keep things simple, I'm going to call the first storage pool Pool 1, and I'm just going to specify that we use all of the disks available in a non-resilient stripe. So the actual ZFS command that's generated by the scripts is zpool create, the name of the actual pool, Pool 1, and then just a list of all the various disk IDs. So as soon as I hit return, that command is now being executed, and then when you see the press enter response, that's the command actually completed. So it took a couple of seconds to effectively create an 803 gig storage pool on which now we're ready to throw file systems and start playing around with ZFS. So it's as simple as that. In the old world that would have been a lot more complex, and obviously that's just a non-redundant stripe. Later on we'll demonstrate using RAID and using mirror and creating mirrored pairs and all of that. So on top of that now I'm going to create a ZFS file system. So I'll select option 2 and I'll just call it pool1/home. You'll notice that I don't put a preceding slash in front of pool 1 because we're actually referring to the name of the storage pool, not the mount point on which it resides, which as you can see here is by default /pool1. So the command that's actually generated, or the command that we would run as a sysadmin in ZFS world, would just be ZFS create pool1/home. Obviously the storage pool needs to exist, so that's obviously returned fairly instantaneously, and now we have a file system mounted on /pool1home which has all of the available storage provided by the underlying storage pool given to it. I'll just create a second one from within that as well, so option 2 again. This time I'll create pool1home pool to refer to my previous statement about creating home directories as specifically file systems. So we'll run ZFS create pool1home pool, and then now we have an underlying file system underneath pool1home. So that's dramatically simplified the way in which we can create file systems and increase the flexibility of which we can use the underlying devices. So these file systems really don't care about the underlying makeup of the physical devices, the physical disks that reside within the pool. We can, as we'll see later on, move the file systems around from a storage pool that just has non-redundant stripes to underlying storage pools that are based on RAID Z or RAID Z2 or mirrored pairs, as long as we have the available space. So this is increased flexibility, and as a systems administrator I really don't have to mess around so much with the underlying physical devices. So now we'll start to look at the file system properties, which is where the ease of administration really does work. So initially I'm just going to view the properties of pool1home pool, and we'll just see some of the options that are available to us. So I'll select option 2, and I'll put in pool 1 home pool. The actual ZFS command that's run is ZFS get all pool 1 home pool, and then you'll see here that there's lots of different property types and their associated values. So you know, as in creation of a typical directory, we can see when the file system was created and how much space is used, how much is available. And if we look at the bottom here, we can see you know, the read and write attributes and all of that, set UID attributes, and obviously we can change those with ZFS set. But we're building in to the ZFS administration framework the capability to turn on and configure a lot of services underlying Solaris or Unix-based services that otherwise would typically take some setting up, some knowledge of underlying files and the configuration of those files and the service management framework and all of those good things. For example, one particularly good example of that is the share NFS property. So not that I would recommend that you share your home directory out via NFS. For the sake of example, we could set share NFS equals on to this particular file system, and that would then go and ensure that the underlying NFS services are started within the service management framework, and then it would share that file system out without having to edit the etc DFS tab and run the share all command. So it dramatically simplifies something like the creation of an NFS share. You can also do the same thing with iSCSI, so you can share volumes out as iSCSI targets. You can change the quota for any particular file system or user if you're using the directory scenario. But one of the really cool things about ZFS is that you can set properties to top level file systems and storage pools, and then unless otherwise stated, underlying file systems inherit those properties as well. So I'll show you an example of that now. So if we just bear in mind that the share NFS value is off at the moment, I'll just go back to the main menu, and this time I'll select option 3, which actually sets the properties of the file system. So we'll use the ZFS set command instead of ZFS get. So again, for this example, I'll set the properties for the top level file system pool 1 home. And this time we're just shown a list of properties for that particular file system. And I'll set share NFS equals on. There are lots of different additional attributes you can set here in the same way that you can put lots of different options in the DFS tab. But for this, for purposes of this demonstration, I'm just going to turn it on. So at the moment in pool 1 home also, the share NFS is set to off. So the command that's actually run is ZFS set share NFS on pool 1 home. And I also had the script run a show mount after that had completed, and that demonstrates now that both pool 1 home and the child file system of /pool has now been shared out to everyone. So if I now go back in and look at the properties of the underlying file system, we can see that those properties have been inherited as well. So NFS is now turned on for the /pool file system as well. So that's just a small example of some of the things that are possible. Another good thing with home directories would be to set quotas. So for example, I could say quota equals 1 gig. At the moment there are no quotas, so however much space is available in the underlying storage pool would be available to this particular file system, and there's a kind of a slush capability there, and all of the file systems associated with that pool would actually share that space, but you wouldn't want necessarily for that to happen in a home directory scenario. You would probably want to restrict people to kind of ensure that they are more aware as to how much space they're actually taking up within their home directories. So I'll set the quota to 1 gig. And the command that's actually run within ZFS is ZFS set quota equals 1 gig and then the name of the file system. And then I'll just run a get command as well, which then shows that that value has been allocated. So if we go back to the main screen now, you'll see that although pool 1 home still has the whole storage pool space available to it, we've restricted pool's directory to only having 1 gig available. And you'll also notice that if you look at the top level storage pool, there's only 161k actually used, which means that that space hasn't actually been reserved, but that will be capped when that user reaches that limit. If you wanted to, you could set a reservation as well, and actually that would reserve those blocks. So we could go on for several more minutes looking at various properties, but that just gives you a good taster as to how simple things have become to change the properties for ZFS file systems. So I'm now going to go back to the top level menu, and I'm going to destroy the file system, and then I'm going to destroy the storage pool, and that will take us to the end of the basic life cycle. So I'll select option 4, and I'd like to destroy, just for example, pool 1 home pool. I get the option with the -R handle to recursively destroy all children. In this case we don't have any, so I'm not going to use that. And there's also a -F if you want to force the changes, which you should use with caution depending on what's happening in that storage pool, in that file system. I'll say yes for this example. So the actual ZFS command that's going to be run is ZFS destroy -F and then the name of the file system. So the command's completed already. And as you can see, that file system's been removed. So to destroy an actual storage pool, and I'll do that by selecting option 5, I'll select pool 1. You get the same sort of options. I'll force it. Instead of using ZFS destroy, we use Z-pool destroy, which relates to the underlying storage pool as opposed to file systems themselves. So when I select yes, that command runs. It's pretty instantaneous, and now we've no data sets available, and none of the disks are being used for any storage pools within our Solaris configuration here. Okay, so following the basic life cycle of a ZFS file system, we're now going to move on to look at some of the more advanced sysadmin commands and delve into some of the deeper capabilities of the ZFS command set. We're going to go through and reiterate some of the things that we've already done, but look at some of the more in-depth options that are available when you create a storage pool, and then when you create file systems on top of those. And then this time round we're going to skip the properties and hierarchy option, because we've looked at that in some detail, and we're going to instead move on to looking at snapshotting, rolling back those snapshots, which of course are made possible because of the underlying transactional object model of ZFS. And then we're going to look at cloning, which kind of builds on some of the things that we'll learn by looking at snapshots in more detail. And then finally we're going to do, so we're going to send and receive a storage pool, or sorry, a snapshot from the main system that we're using here onto a remote X4100, and just try to explore some of the capabilities of send and receive. As you can see in this top level menu, there's lots of other capabilities within the scripts, which again you can download from sun.com. These are all fully functional, so feel free to get the scripts and play around and use this as a training aid to understand all of the different commands that are possible and how you can build those commands up. So I'll start off by creating another storage pool, because the way that we left off by destroying the pool during the basic menu, we've left ourselves with no ZFS pool at all. This time round, so I'll select option 1, and this time round the difference being that we're going to start looking at exploring creating mirrored storage pools and pools using RAID Z or RAID Z2. In this case we're just going to use RAID Z. Tim explained in the presentation earlier the difference between the two. So I'm going to select option 1 and create a mirrored storage pool. So again, for simplicity, I'll call it pool 1 again. And I'll just select the first 2 disks that are available within the J4200. And then I'll say yes, I want to create another mirror, which effectively uses another top-level virtual device. And then I'll select for that second mirror, which is going to exist within the same storage pool, the next 2 available disks. And that will probably do for the examples that we're using here. And as you can see, we're already building a portion of the ZFS command set here within the scripts. Again, all of these kind of questions are just something that we've created within the scripts for the ZFS Discovery Days. So all the way through, a lot of the commands within ZFS, you have the option to use the -n handle, which effectively allow you to view a dry run so that you can actually see what the command will look like when it's actually running, but no changes actually take effect. In this case, we're not going to use that because we do want to make these changes. And if you want, you can force them, but we don't have to. That just adds a -f onto the command. So I can, if I like, create a mount point, specify a mount point. I could either do this now, or I could move the mount point within the ZFS set properties command set as I described earlier. But just for the sake of example, I will create a mount point, and I'll say export. We'll say ZFS. If I don't specify the -d and then a specific mount point, the default would just be to mount it in slash. So I'd have /pool1. In this particular case, the mount point will be export ZFS /pool1. And then, as Tim referred to in the presentation which accompanies this demonstration, we have the capability to add specific devices as log devices for the ZFS intent log, or as cache devices for the level 2 ARC. There's also the ability to add specific devices as hot spares, which can be shared between storage pools, which effectively are non-active disks that can then take place of another disk if there's some kind of if that disk becomes degraded, for example. So in this particular example, I'm just going to add a hot spare because we don't have any solid-state disks available to us in the hardware configuration we have in this particular instance. So I'm just going to type in spare. And then I'm going to scroll back up the screen just quickly and select the next available disk in the pool on the JBODs. Oops. So I don't want to select anymore, but I could add more at a later date if I wanted to. So then at the top of the screen, we now see the actual ZFS command that's going to be run. So zpool create to create a storage pool, -m to specify a mount point, and we're going to call the pool pool1, and then we're adding 2 mirrors. So we've got mirror and then 2 disks, and then mirror another 2 disks, which defines 2 top-level virtual devices, and then the name of the spare device. So I'll run that command. That's executing now, and now it's completed. So in a couple of seconds, what we've actually done is generated across 5 disks 272 gig of available space, which is effectively the capacity of 2 disks, but we've also mirrored 2 pairs, and we have another disk waiting available to give us additional redundancy. So before I move on to actually creating file systems, I think it's probably important now to demonstrate the creation of a RAID or a RAID Z storage pool. So I'm going to destroy this particular storage pool and run through that again using RAID instead of mirrors. So I'm going to move back to the top level, and I'm going to select option 13 to destroy the storage pool. I'm going to destroy pool 1, and I'll say yes, I'll force the changes, and that, as we saw before in the previous life cycle, it just runs zpool destroy and then the name of the actual storage pool. So that should now be gone. So we'll now move back into option 1 again and create another storage pool, this time selecting the RAID option instead of mirror. So option 2. I'll again call it pool 1, and the script just asks me whether I want to use single or dual disk parity, which is effectively the difference between RAID Z and RAID Z2. We can afford to lose as many disks as we have parity, so if I select RAID Z, then I can lose one of the disks within my RAID set and still maintain data integrity. I lose the redundancy, but obviously I maintain the integrity. So I'll select 1, because we only have a certain number of disks available to us. And then I'm just going to choose to include the first 3 disks in the JBOD array. If I wanted to, I could create another top-level VDEV here, but I'm not going to. I'm not going to create a dry run, and I don't need to force the changes. This time round I won't specify a mount point because we've already seen the -m flag in operation, and I don't think I need to create any hot spares to demonstrate that part of the command set either, because we've been there before. So simply the command that's actually generated zpool create pool 1, and then instead of mirror you now specify RAID Z and then the disks that you want to include within that RAID array. And that's now completed, so within less than a second we have 408 gig of usable storage space spread across 3 devices on an internal JBOD. And that's now ready to use. We can start throwing file systems at that. So I'll move back to the main menu. I'm now going to create a ZFS file system, but this time round I'm going to show you how to create a volume, which is effectively representative of a virtual block device, as opposed to an actual file system. So if I select option 1 to create the new file system, and again I'll call it, well, this time round I'll call it backup. So pool 1 backup, and the scripts ask me, do I want to create a volume? I'll say yes. So effectively this volume won't have a mount point, and it will be a virtual block device, if you like. I can specify the overall volume size. I'll just say 1 gig for the sake of this example, and if I wanted to I can specify the block size, so we'll just say 1024. So we're asked here whether we want to create a sparse volume. It's not generally recommended, because funny things can happen to block devices if the underlying space that it expects to be available is taken up by other elements of the storage pool, other file systems. So by creating a sparse volume, we effectively don't reserve the 1 gig of space that I'm actually allocating to this volume. So I'm not going to use that. I'm going to say no. The text there effectively lets you know that if you wanted to, you could also use the -O option here, and then specify properties as we saw within the ZFS set and ZFS get command set earlier on. But because we've kind of demonstrated that in a different way, we don't need to do that here. So the actual ZFS command that's generated by the scripts is ZFS create -V to say that we're creating a volume as opposed to a file system here, and then how big we want that volume to be, what block size we want to use, and then the actual name of the volume. So I'll run that command, and that's been created. If we go back to the top level menu, we can see here now that we have pool 1/backup, but you'll notice that there's some subtle differences as opposed to when we created file systems earlier on. So there's no mount point for a start, and secondly, if you look at the top level storage pool, you can see that 1 gig is used up. Because we didn't create a sparse volume, we've actually reserved the blocks that are allocated to pool 1 backup. What I'm going to do now is create another file system which isn't a volume for the purposes of the remainder of the demonstration, and then I'm going to destroy the volume that we just created, just to clear the screen effectively, so that when we start looking at snapshots things are clear. So I'm just going to create a new ZFS file system. I'm going to call it pool 1 home again. I don't want to create a volume this time. So we're back to the simple command ZFS create pool 1 home, and that's complete. So if we now move back and use option 12 to destroy the volume, I'm going to destroy pool 1 backup, and we'll just put all the options that are available here. So effectively we're just destroying that volume we created.